Okay, hello fellow earth scientists. It's Mr. Avery and Miss Teven, Earth Science class. We're trying to get you guys ready for the rock and mineral test. And I've told all you guys this is going to be the toughest test you guys have had. So my advice to you is watch this YouTube video once or more than once. Preferably more than once. So watch it, learn. We're going to try to give you a quick course on what you need to know for the test, which is this Friday and Monday. So pay attention. The first thing we're going to talk about is minerals. Minerals. What are the properties of minerals? They have to be, one, natural. Right? They have to be naturally occurring. Two, they have to be inorganic. Inorganic, which means they're not organic. They can't come from a living thing. Three, they have to be a solid form. Means they can't be a liquid or a gas. Four, they have to have a chemical and crystal composition. I'm writing fast to make this fast. So, what are the different tests for minerals? We have different tests, mineral tests. We talked about how you test for minerals. The first test is color, least reliable. We can do that with sulfur because it's bright yellow. We can do a streak test. We need a white plate to do that, and we get the powder color. Luster is how the light reflects off the mineral. We can break it. It's called breakage pattern. So it's either going to be cleavage, right? Breaks apart into sheets, or it's fracture, which means it can break apart in any random pieces. Hardness is another test. Hardness. Diamond is the hardest at a 10. Talc is the softest at a 1. Anything that's harder on the scale can scratch anything lower. Density, which we also call specific gravity, which is mass divided by volume. All right, so we know we have different mineral groups, right? Mineral groups. We have to know the groups. We have silicates, which is the largest mineral group we have, made of silicon and oxygen. The largest, most abundant mineral we have. Carbonates. Carbonates made of carbon and oxygen, the second most abundant. We have oxides. Oxides, which is oxygen and a metal. And then we have native elements, which is just one basically element, like gold, silver, even salt is just one. It's a native element. Those are your main mineral groups. So now we got to know the uses for minerals, and we're going to talk about that in a second. Now I'm going to talk about the rock cycle. Rock cycle, right? So we're going to have different boxes. So you're going to have a box that says igneous. It's going to be a box, right? You're going to have to figure it out. We have a box that says sediments. If I can write today, sediments. And then we're going to have a box that says sedimentary rocks. I'm trying to go fast, so my handwriting is not real neat. And then we have magma. That's a box. And then we got metamorphic in here. The key to figuring out the boxes is the processes. So for magma, we know it's a liquid, right? So to go igneous, it has to solidify. Solidification. If I can spell. Solidification. It gets hard, becomes an igneous rock. So from here, we get, after igneous, it might weather and erode. That breaks it down into sediments, right? So after sediments, we're gonna talk about lithification. Lithification, which we know is compaction and cementation, right? Cementation. I apologize, I'm writing very fast. We call that C&C. So it basically gets glued back together and becomes a sedimentary rock. Now to become a metamorphic rock, you're gonna put heat and pressure on the rock. heat and pressure, then it becomes a metamorphic rock. Over here, we've got to melt it, right? Melting. To turn any rock into magma, you're going to melt it. So know that any one of these can come across and skip a cycle. If you put heat and pressure on any of these rocks, you might make metamorphic. If you weather any one of these rocks, it might erode and become a sedimentary rock. So just know that to become a rock, the definition of a rock is more than one mineral. So every rock is minerals just glued back together, melted or heat and pressure, and that's your rock cycle. You got to know the rock cycle. It goes round and round. Okay, I'm going to turn it over to Miss Teven. She's going to talk about some of the rocks themselves.
First, we're going to be talking about very important minerals you need to know. Halite, we use this as a food additive. NaCl, sodium chloride. Hematite is mined for iron. Look at those, look at that oxidized metal in there. Sulfur, all of you remember that with the rotten egg smell. Galena, very, very dense metallic luster. Look at that cleavage. Graphite, hey, it's a pencil. Gypsum, used in drywall. And we have pyrite. It looks like gold, its streak is different. Pyrite is fool's gold. And we have calcite. Those are some important minerals you need to know. How do we know this is calcite? Well, if we drop some hydrochloric acid on it, it is going to chemically weather. And then we have our quartz. This is the most abundant mineral made of silica and oxygen. We use it in glass and electronics, and as you can see, it comes in a variety of colors. We're going to now look at our rocks, starting with metamorphic. Keep in mind, metamorphic, pressure and heat. We've got two types of metamorphic. We've got foliated, which means banded. If you take sedimentary rock called shale and it undergoes heat and pressure, you will get slate. Okay, and we can see with increasing heat and pressure of slate, we're going to get schist. Fine piece of schist there. And schist under heat and pressure, you're going to get some really, really nice rocks called gneiss. In our non-foliated or no banding metamorphic rocks, we've got sandstone under heat and pressure, which will give us quartzite. Marble comes from limestone. Under heat and pressure, gives us marble. You do not want to put a marble statue in acid rain. It will chemically weather. Why? It has got calcite in it. Our igneous rocks. Igneous forms from melting, cooling, crystallization. We've got two types. We've got intrusive, formed from magma, slow cooling. Why? Because it cools inside Earth. Large crystals. Look at those beautiful crystals of granite. Granite, an intrusive igneous rock, large crystals, it forms our continental crust. Extrusive. This is fast cooling because it comes from lava. Small crystals, okay? And we've got a good way to remember it, and it's called BOP, basalt, obsidian, pumice. Basalt makes up the oceanic crust. Obsidian, volcanic black glass. And pumice, it's very vesicular, lots of little holes in it, making it less dense than water. Our final type of rock we're going to take a look at is sedimentary rock, made from weathering, erosion, deposition, compaction, cementation. Sedimentary rock is very important to us because with it we know about ancient life, because a sedimentary rock is the only type of rock with fossils. Clastic, two types, clastic, non-clastic. We have clastic, which means we have particles compacted, beautiful conglomerate, look at those pebbles right there. Sandstone, you can see the sand in that, and you can actually see layers. Shale is made of compacted clay. Now, non-clastic rocks, we've got coal, okay? And this is biologic or organic sedimentary rock. Coal forms from ancient swamp plants, and it's a very, very important fossil fuel for us. We have limestone. Limestone is made of ancient shells of marine organisms. We use this a lot in construction. And chemical, non-clastic rock salt. This comes from the evaporation of ancient oceans, and it is made of halite. Thank you very much. Study, do well for the test.
Okay, guys, good luck.